Bonjour, hi, I'm Denis Gagné from Trisatech and welcome to this Trisatech webinar. Today we have the privilege of having with us Bruce Silver, who will talk to us about standard-based low-code business automation. Bruce is world famous for his method and style on how to create process, case, and decision documentation using the international standards BPMN, DMN, and CMMN. And today, Bruce will give us a quick tour of what it means to use standard-based low-code business automation. So Bruce, if you want to share your screen, we'll have you right there.
Hi, I'm Bruce Silver, and I want to show you something today that you may not know you could do with the Trisatech platform, and that is low-code business automation based entirely on standards, BPMN and DMN. Business automation, also called digital transformation, automation of manual tasks and processes, moving work to digital online. No doubt this is a key initiative in your own company, a result of globalization, the cloud, proliferation of public APIs, even COVID. I have no doubt you're all trying to do this. Low code means software development based on models, diagrams and tables, plus some business-friendly formula language, not code. So getting a minimum viable product out the door does not require waiting for some overstretched IT resource to become available. Product owners, product managers, or subject matter experts can do it themselves. Gartner says that by 2024, 65% of all application development will be low code. The key reason? Time to value. So what can you do with low-code business automation? Most products that advertise themselves as low-code or no-code platforms are just used for small situational apps, mostly in HR and CRM. That's not what I'm talking about. I'm talking about automating core business functions. For example, in healthcare, things like care plan coordination or pre-authorization for some procedure. In banking, things like digital mortgage underwriting or posting accounting events to the general ledger. I'm talking about creating new capabilities quickly, getting a minimum viable product out into the marketplace fast for customer feedback, and turning around suggested changes quickly as well. We can do that because we're not building everything from the ground up. Business automation is mostly composition and reuse of existing services. In low-code business automation, you're composing individual services, mostly created by others, through their REST APIs. Today, REST APIs are everywhere. There are thousands of public APIs available for free or low monthly subscription. Here you see just a small sample from one of many API aggregators. You can find a public API for just about anything you need. Just grab the API, import it into your model's operation library. In addition, there are REST APIs for services created by you, business logic created in DMN, and executable subprocesses created in BPMN. Business automation modeling is quite different from BPMN for documentation. Modeling for documentation is non-executable. It's done by business users who just need to know the names and order of the process steps. Activities are described only by a label and whether human or automated. Process data is not defined, so the challenge is simply to communicate the process logic, what happens in what order, clearly and completely from the printed diagrams themselves. That requires additional conventions, such as BPMN method and style, which defines a small bit of data implicitly from things like gate labels. For example, the automated task auto approve vacation here has an output variable with allowed values approved, refused, or referred to manager. Modeling for automation is different. Not all business users can do it. It requires some facility with data and basic logic formulas, but if you can create spreadsheets using the formulas ribbon in Excel, you can do it. The BPMN you're creating is executable, so there's a lot more detail in the modeling. In addition to the activity flow, these models represent the data flow and configuration of each task type to invoke some service, and mapping between the process variables and the service parameters. Here, the challenge for modelers is different, making the process you've diagrammed run without errors and return the correct result. That's quite a bit harder, but it's all low code, not programming. Each task in executable BPMN is a service, an action performed on request using a REST API. Each service operation performs a particular action, and related operations are grouped into an interface with a common server URL and authorization credential. The TriceTech operation library defines the elements required to call the API. The URL, composed of the server URL and operation path, possibly followed by query parameters. The name and type of authorization credential required. And for each operation, the path, the input parameters, and their data type, and the output parameter and its data type. For example, here, the task standard IP lookup calls an operation defined by the operation library entry you see here. Incorporating a public API in business automation has 3 steps. First, you need to create an operation library entry for it. Here for the task standard IP lookup, we did it automatically by dragging in a TriceTech connector. We can also generate the entry automatically by importing an OpenAPI file or an OData file, or manually from API documentation. Step 2, bind a BPMN service task to the operation. Just click on the task type icon and select the operation from the operation library. Operation inputs become the service task inputs, and operation outputs become the service task outputs. Step 3 is mapping process variables, the data objects, to and from the task variables, meaning the service inputs and outputs. So you see process variable myIP is mapped to the task input IP address, and the task output geolocation information is mapped to the process variable myLocation. The mapping uses boxed expressions and feel borrowed from DMN. In addition to public APIs, your own DMN and BPMN models expose REST APIs you create yourself. For example, the decision task validate vacation request is business logic that checks the process data input vacation request for correctness. The validation logic is defined in the DMN decision model. Here we see its decision requirements diagram, or DRD, which diagrams the logic dependencies. Ovals are the input data, values supplied to the model at time of execution. Rectangles are decisions, each with a value expression that returns an output value for a given set of input values. The unit of execution of a DMN model is a decision service with specified service inputs and outputs. Here the service inputs are the input data, and the service outputs are validation errors and employee record. The decision federal holidays is used in the logic but is not an output of the service. In BPMN, click on the task type icon to bind it to the decision service. As we saw previously, the service inputs become the task inputs and the service outputs become the task outputs. Finally, data mapping maps process variables to and from the task inputs and outputs. Here we just see the input mapping, where the table Employee Vacation Data, a cloud data store, is filtered to extract a single record matching the employee ID of vacation request, again just using boxed expressions and feel. Data objects do not retain their values when the process completes, but cloud data stores, a new feature of the platform, do. Data stores act as a simple database inside the TriceTech workspace. A data store is a process variable holding a single data table. It is accessed by a data association just like a data object, but accessible also externally using either a management utility via Excel on the desktop or an API. So here in this vacation request process, the data store employee vacation data holds a table of employees and their accrued vacation time. The input mapping to decision task validate vacation request extracts the record for the employee matching data input vacation request, a field filter expression. And there's more. You can REST enable your own databases and apps using the OData standard. For example, here I use the Skyvia Connect Data Gateway service to generate a REST API for a MySQL database on my own website. The gateway generates an OData metadata file that I import into the operation library, and REST APIs for 5 operations per database table are generated automatically. You simply bind and map service tasks to these operations just like with public APIs. Let's look at a simple example. Here's a business automation service that returns 10 restaurants near me, where my location is derived from my IP address. The BPMN looks like this. 2 service tasks, a data input myIP taken from myip.com, a data object myLocation, and a data output restaurants, a list of restaurants returned by the service. The first task returns myLocation as a string latitude, longitude using the IP stack geolocation service, which is in the TriZetech connectors library. The second task uses the here.com geolocation API to return a list of restaurants near the data object myLocation, which we map to data output restaurants. Here, variables are modeled as field data types. Most task variables are defined by the service provider. The process variables are the data inputs, data objects, and data outputs. We define those. Data flow is shown explicitly in the diagram as data associations, represented as dotted arrows. Data flows from data inputs to task inputs, from task outputs to data objects, from data objects to other task inputs, and ultimately from task output to a data output. Each data association represents a data mapping defined in task configuration. For example, here you see a fragment of the task output geolocation information. The data association to myLocation maps the component's latitude and longitude to a comma delimited string. So let's see how to model and deploy this business automation service. Okay, so here is our process, partially completed. Let's go to the connectors library. We drag out standard IP lookup from the connectors library and we place it in the process, hook up the sequence flows, connect the data input myIP as an input to this task, and output of this task goes to the data object myLocation. And when we do that, the operation library is populated for that service. The IP stack API, there's the interface, there's the operation. We look at, it has 2 inputs, IP address and language, and an output geolocation information. We look at the type of that. Wow, it's got a lot of detail. But we see 11 and 12, latitude and longitude, both numbers. Let's remember that because myLocation, the data object, wants a comma delimited string. So we're going to have to convert those numbers to that. So let's do that in the data mapping. So myIP gets mapped to IP address. You just enter that there. The code completion helps us out. Language is just the literal string English. So we type that in. And then in the output mapping, there's my location, this comma delimited text based on geolocation. And so we need to cast those latitude and longitude to a string. So string of geolocation dot latitude plus, which is the string concatenation operator, literal value comma, and plus string of geolocation information dot longitude. And again, you can see how the code completion helps us select variables in scope. That's all we need to do there. Okay. Okay, we're ready now to model restaurants near me. We've already imported the Open API file to the operation library. So we have the interface and its operation. We need to bind the service task to that operation and then do the data mapping. So if we click on the gears, we can select that interface, geocoding and search, that's the here.com, and the operation is called discover, and the data mapping. So here's the data mapping. We have a process variable input called my location, latitude, comma, longitude, and that goes in the at input, my location. Q is the feature we're looking for, so we'll just enter the literal value restaurant. And the other input we need is the limit. We want 10 restaurants returned. That's all we need to do there. The output mapping is going to a data output called restaurants collection of text, and the service output is called search results. We can look at its data type here, and it's called search results, and if we want to look at what that type is, it's a collection of components called items, and each item, expand this, wow, there's a lot of data in each item, but what we want is the address label, address, and address has a lot of components, label. So if we map it to items.address.label, that's going to give us the name and address of the restaurant. Okay, so that's what we want to do here. Let's back out of that. So it's search results, that's the name of the output, dot items dot address dot label. Okay, that's all we need to do. So let's close this. So we've configured now the this process, the data flow, data input to the task input, task output to the data object to this task input, and task output to the data output. That's perfect. So let's save our process. Go to the execution ribbon, cloud publish, and I've already entered the identity for the services. That's where we put our API key, authorization credential. Click publish, And it says View Publish Process in the Service Library. And click Form to run it. And it wants my IP. So go to myip.com, which I've already done. Let's copy the IP address there and go here and paste it in. Submit. And here we have 10 restaurants near my location, Pasadena, California. And that's all we need to do. Here are a few takeaways from what we've seen. First, almost anything you need is accessible as a REST API, one way or another. You can find a public API, create the operation library entry for it, usually automatically, and bind a service task to it. Or create your own business logic in DMN, define it as a decision service, and bind a BPMN decision task to it. TriceTech automatically creates the field data types for your service inputs and outputs. Second, use field and boxed expressions to map the data flow from data input to task input, etc., as we have seen. And since we know the data types, the code completion feature helps us with the mapping. Third, compiling and deploying BPMN as a REST service is so easy, just one click. Fourth, while modeling for automation is quite a bit more detailed than modeling for documentation, it uses the same graphical language, BPMN, and most important, it's all low code. There's no programming. You do need to know field and boxed expressions. The little restaurants near me example is very simple, but I've used the same techniques in projects doing digital mortgage underwriting, financial accounting, things like that, so they can handle complex real-world scenarios implementing core business functions. But if you're a product owner or product manager, business architect, or subject matter expert, it means you can do it yourself. And if you're a programmer, it means you can do it much faster than with code. But there are a lot of details in the modeling. Each task type, decision task, service task, user task, script task, and call activity plays a specific role and has specific configuration details. Not hard, but there are many things to learn. And to that end, I've just introduced 2 new courses that show you how to do it in detail. Both are self-paced e-learning with lots of hands-on exercises using the TriceTech platform and tools. Each course includes 60-day access to my TriceTech workspace and post-class certification. The first one is DMN Method and Style, completely revised and updated with new features of DMN 1.4 and the TriceTech platform version 11, streamlining the material and emphasizing the things you need for business automation. If you've already taken DMN Advanced, you don't need to take this new course, but if field, boxed expressions, BKMs, and contexts are new to you, you should take this course before tackling business automation. If you order DMN and business automation training together, there is a significant bundling discount. The second course is Low-Code Business Automation, focusing on all those details of executable BPMN. It assumes the student has a good familiarity with field and box expressions. It's one course divided in 2 sections. The basic section explains all the techniques, including details of configuration of all the task types. There are very many exercises using the tool, and it ends with creation of the vacation request workflow process. The advanced section is essentially all hands-on, creating a stock trading page flow app. It adds 2 more basic techniques important in real-world projects, creating operation library entries manually from the service provider documentation, and REST-enabling relational databases using OData. Each student is provided his or her own MySQL database and a REST endpoint linked to it. I hope I've gotten you thinking about the possibilities for your own organization, things you might have previously thought were impossible or would have to wait for programming resources to become available. I urge you to watch the free introduction and overview videos using the links here, or they're also on the Learn ribbon of the TriZetech tools. And I've also provided links to register for the courses. And with that, I thank you, and if there's time, we can take some questions.